Hi, Mr. Spone here, and today we're going to talk about why we have seasons. We're going to answer this question fully. Why is there summer, spring, winter, fall on the planet Earth? So, before we begin that, we do need to know a little bit about orbits. And here we have the Earth, and the Earth does orbit around the Sun, but a lot of people think that the orbits are circular, when in fact, orbits are slightly elliptical, as the picture shows. Um, Johannes Kepler was a scientist who is famous for coming up with this idea. He came up with the Kepler's laws of planetary motion. And he said that the Earth and other planets have elliptical orbits around the Sun, not perfectly circular ones. So the orbit of the Earth around the Sun is slightly more like an oval or an egg shaped than it is circular. This picture is highly exaggerated, though. And also, I want to talk about what is a year. We should know that. You should know what causes a year, what makes a day. And I want you to compare and contrast the planet's distance from the sun in a circular orbit on the left versus a elliptical orbit on the right. So I think these are going to move. The Earth goes around the sun in an elliptical orbit. Notice its distance. Right now it's closer to the sun. Over here it's getting further and further away from the sun. In a circular orbit, what we say is that the Earth is always equidistant from the sun. Its position is changing, but it's never a different distance away from the sun. So that's important to look at. And here's just some text saying exactly what I just told you. A year, by the way, is the time it takes the Earth to go around the sun once, the time it takes to orbit or revolve around the sun. A day is defined as the time it takes Earth to spin once on its axis. We spin towards the sun and away from the sun. That's why we have day and night, a cycle every day. So keep that in mind. So these are on the text that we just talked about is on a PDF of the PowerPoint if you need to read it. Circular orbits are equidistant. And a elliptical orbit, the Earth's distance from the sun does change a little bit. All right. So there are some special terms here. When the Earth is closest to the sun, they call that perihelion. Helion refers to the sun, helios. And when the Earth is at its furthest approach from the sun, they call that aphelion. Just two terms, and I do want you to know that the Earth goes from about 91 million miles to about 95 million miles. So at point 1 over here, the Earth is about 91 million miles away from the sun, and at point 3, it's at about 95 million. So the Earth does vary millions of miles in distance from the sun throughout the course of a year. And you have the definitions of perihelion and aphelion if you need them. So, are seasons caused by the Earth's changing distance from the sun? And that seems like they should be. You know, if you're closer to the sun, it should be warmer. Here I have a handy little torch. I don't know if you can see this, a little camp burner. And if I open up the gas and I turn this on, nothing happens because I turned it off. And you can actually see that very, very hot. We know that if you're far away from the heat source, it's not as hot. If you get closer, it gets hotter and hotter. So it should make sense. Same thing is true if you're at a campfire. The closer you sit to a fire, the closer you sit to a heater, the warmer it gets. So the Earth does get millions of miles closer to the sun throughout the course of the year. So it's only natural for people to think that, well, we must be in the summertime when we're closer to the sun. Mercury is very close to the sun. It's extremely hot on Mercury. Pluto, the dwarf planet, is extremely far away from the sun. It's extremely cold there. So common sense and intuition tells us yes, but science and some other facts tell us that this is not the case. It's a common misconception. In fact, look at this picture right here. Notice when we are closest to the sun. What month is it? January, typically the coldest time of the year. In fact, it is winter when we are closest to the sun. So we can't use distance to the sun as an explanation for our seasons. It doesn't work. The simple fact that we are closest to the sun during the winter in the northern hemisphere basically overrules this. So we have to come up with another explanation. And this is pretty bizarre. We're closer to the sun when it's colder. Doesn't make a lot of sense, but it will by the end of this video. Why doesn't distance matter? In extreme cases, it does. Again, Mercury versus Pluto. Mercury is super close, super hot. Pluto is super far away, super cold. But again,
The Earth only varies from 91 million to 95 million. That seems like a lot. 4 million miles definitely seems like a lot. On Earth scales, that's a huge distance. But imagine you had two individuals and one was 91 feet away from a wall, one was 95 feet away from a wall on the right hand side. Comparatively, they're not that much off. One's only four different than the other, 4 out of 95. And if you were to look at the average of these two guys, they're both, and you average their distance away, like the Earth. The Earth goes from 91 to 95 million miles away. So the average is roughly 93. Doesn't work out perfectly because of Kepler's second law. But basically, you have an average of 93. So you're going from 91 to 93, 93 to 95. You're only off by like two. And the Earth's orbital distance only varies by about 2% throughout the year. On average, the Earth is 93 million miles away from the sun. And another way to explain this, maybe to help to think about money, if you own $2 and I stole one of your dollars, percentage-wise, what have I taken from you? Half your money. I've taken 50% of your money. That's insane. You're like, oh, you stole 50% of what I own. But what if you had $100 and I still stole that same $1? Well, now I only took 1 out of 100. I only took 1% of your money. So even though the sun does vary by 4 million miles, it's only a small percentage of the or the Earth's total distance from the sun. So that's why distance doesn't really matter for seasons from our perspective. Percentage-wise, that millions of miles, that few million mile shift is only a small percentage of the total distance from the Earth to the sun. So other things we do need to know is that seasons are opposite in the opposite hemispheres. Summer in the northern hemisphere is winter in the southern hemisphere. Winter in our northern hemisphere is summer in the southern hemisphere, and spring and fall are also reversed. And the truth be told, just to give you the answer now, it is the tilt of the Earth that causes the seasons. You probably heard of this in middle school or grade school. The Earth kind of, I don't know, drunk. It wobbles as it orbits the sun, and it's actually tilted a little bit. The Earth is not perfectly upright as it spins. It's at an angle, 23.5-degree angle, or 23.4. And basically, the Earth's axis has a tilt. And it's this tilt that is actually the main driver of climate and seasons on Earth, our seasonal cycle, on the small term. When a hemisphere, like look right here, we have the northern hemisphere up here, this is tilted towards the sun on the left. So that's going to be summer. That means the southern hemisphere is tilted away. The bottom part is kind of tilted away from the sun. That's winter. And if we were tilted away from the sun, we would be in winter. So it is this tilt of the Earth that causes our seasons. And we're going to look at this in much more detail in the next few slides. So I have an image here, and basically you have a planet that is not tilted. Let's imagine this is the Earth. You have the northern hemisphere, the southern hemisphere. You have the sun on the right. The sun is huge compared to the Earth. Its rays are coming in. And if there was no tilt to the Earth, if the Earth was not tilted at all, basically this shading shows the sun's heating. The northern hemisphere and the southern hemisphere would receive the same amount of heat. So there would be no summer here, winter here. It would not be like that. But because the Earth is tilted, look at this image down below. The Earth is tilted towards the sun. And again, this half of the sun is still being shaded. This half of the Earth is still being shaded. But look at how much of the northern hemisphere is being shaded compared to the southern hemisphere. If the planets weren't tilted, like up top, the northern and the southern hemisphere receive the same amount of heat. But now, because this whole planet is tilted, well, more of the sun's rays are in the northern hemisphere. So when you're tilted towards the sun, the northern hemisphere is getting more heat. The southern hemisphere, which is tilted away, is getting less heat. And again, the text on these slides says exactly what I am telling you. You can read it. You can pause it. It is on the PowerPoint I'm giving you. I just want to go through this with you before you do these worksheets on your own. So again, right here, in this case, we have a planet that is not tilted. North Pole, South Pole are straight up and down. There's no 23.5-degree tilt. The sun heats the hemispheres equally. This would not lead to seasonal variations between the hemispheres. But when you're tilted towards the sun is this way. You're tilted towards the sun, you get more light. This is summer. I'm just reiterating what we did on the last slide. You're tilted towards, it's summer. You are tilted away. It is now going to be winter in the northern hemisphere. We are now tilted away from the sun. If the sun's over here, we're tilted away from it. We are getting less light in the northern hemisphere. And the southern hemisphere is receiving the brunt of the sun's heating. So that means it's going to be summer down there. All right, following so far? We look at this picture. This picture is pretty cool. You have the sun in the middle and the earth is orbiting around it. And basically in June, when it's hottest for us, notice that the northern hemisphere is tilted towards the sun. And as the earth moves around, that tilt stays the way it is. So as it turns out in December, we're still tilted at 23.5 degrees, but we're tilted away from the sun. So over here in June, we're tilted towards the sun. Over here in winter, we are tilted away from the sun. So that's why we have summer and winter. And of course, spring and fall are kind of in the middle of these two seasons. You know, the earth is going from being tilted towards the sun to slowly being tilted away from the sun. So it's going from really hot, less hot, less hot, less hot, less hot. You know, it's basically fall. It's getting colder, 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 winter. Now we're tilted fully away from the sun. Now we're starting to increase our tilt towards the sun. It's getting warmer, 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 spring, still tilting, warmer, warmer, warmer. And we keep going through those seasonal cycles. So it's this tilt of the earth that is causing our seasons, not the distance from the sun. And why does the tilt matter? So we're just going to answer this question before we conclude this video. So the earth is tilted. Well, we already answered this in one section. When it's tilted towards, the northern hemisphere is just receiving more light. And that's one answer you can put down, certainly on your question sets or answer that question. The northern hemisphere just receives more overall sunshine, so it's going to be warmer. But we're going to also talk about how tilted light works. And there's going to be three things we're going to look at. So one, I want you to imagine we have three flashlights here, and one is pointing down at the table, one is at an angle, and one is at a steeper angle. Now notice how the light spreads out when it strikes the surface. This flashlight right here, it's basically shining right here on this much surface. This one, well, this is bigger right here than over here. The light is actually spreading out at the surface. It's less intense, it's less concentrated. And over here, if you have a very steep angle, well, this light is spreading out over a very, very, very large surface. So when the sun is at an angle to us, when we're tilted towards the sun, the rays are more concentrated, they're more direct. When we're tilted away, we end up with sunlight like this case. The rays spread out. So this is the first reason. Tilted rays are less concentrated. So when we're tilted towards the sun, more direct sun rays. When we're tilted away, the rays are tilted and spread out at the surface. Another thing to look at, the distance that it has to travel through. These lights are now equally high off the ground. And imagine this is the sun traveling through the Earth's atmosphere. Well, this light has to travel through about 6. This is a millimeter scale, but it has to 6 units from here to here. This light, same distance off the ground, but it has to travel through like 10 units. So when the sun's rays are tilted, the sun actually has to pass through more atmosphere to reach the surface. So some of that heat is going to be dissipated and used to warm the atmosphere and lost. So that's answer number 2 on why tilted rays, that says tidal rays, it should say tilted. I'm not going to change it till afterwards, so keep that in mind. So tilted rays basically have to travel through more atmosphere to warm the earth. And the third is, we know that in the summertime we have longer daylight. We have more hours and minutes of daylight, so there's more heating. The day is longer in the summer, so we have more sun. And also, don't forget the original reason, that basically when the northern hemisphere is tilted towards the sun, more of the northern hemisphere is receiving sunlight. So that's why the whole northern hemisphere has summer when the southern hemisphere has winter. And this is kind of telling us the 3 reasons just why how tilt works. Also recall that it's hottest in the middle of the day, usually when the sun is at its highest point in the sky. Sun is not directly overhead for us. Remember, you got to think about your equinox things. We're tilted at 23.5 degrees, and we're at like 42 degrees latitude. So you got to think about when the sun is directly overhead or not. But when the sun is at its highest point in the sky, you know, how high the sun goes changes throughout the year. In the winter, the sun only gets as the sun's very low. In the summer, the sun gets a little bit higher in its point in the sky, so we get more direct rays. That's something to keep in mind. But that is number 3 as an answer. And that concludes our discussion of why we have seasons. Hope this answers it for you and you enjoyed this presentation, Mr. Spohn.